Okay, so as promised, a question that could be asked for your HSC is this one here, where we have a tank with 10,000 litres of salt water. The concentration is 1 kilogram per 100 litres. Fresh water is being poured into the top at 20 litres per second, and the well-stirred mixture is leaving at 10 litres per second. So we want to develop an equation that tells us the amount of salt at any time t. So we're going to use differential equations to do that. We know that the amount of salt changing over time, the rate at which it changes, is the rate of the salt entering minus the rate of the salt leaving. And this is why we've chosen this one, because in the previous video, we came up with a legit equation, but in our syllabus, we only do separation of variables. We weren't able to use an integration factor, so we couldn't really continue to develop the equation the way we would have liked to. So in this one here, we're going to write down that dq dt equals. Now the rate of salt entering, no salt is entering, because we've changed the example now to have fresh water. So it's going in and it's diluting the solution, so it's making an impact on this situation, but no actual salt is entering over time. So the rate at which salt is entering is 0. Now the rate of salt leaving, all right, so we have 10 litres per second, and now we need to work out how much salt and what volume, so we can work out the concentration leaving. 10 litres per second of what concentration of salt is leaving? Well, there was a kilogram for every 100 litres at the start, and there's 10,000 litres, right? So there was 100 kilograms, if you work that out, 100 kilograms of salt at the start in there. And there was 100 kilograms of salt in the 10,000 litres that was in there at the start. So I'm going to say at the moment there's Q. That's the amount of salt, Q kilograms of salt. And I want to know what the volume of the salt is, the volume of the tank is. Well, it was 10,000 litres, but we're putting 20 litres in and taking 10 litres out. So all the time, we've got a volume changing by 10 litres every second, right? So I'm going to put my volume as being the 10,000 plus 10t. So after 1 second, it's 10,010 litres. After 2 seconds, it's 10,020, because 10 times 2 is 20. And that is the volume on the bottom there in litres. Q kilograms in whatever that volume is, which changes over time, but that's okay. All right, so that litres cancelling out, and we get dq dt equals minus 10q over 10,000 plus 10t, and it's kilograms per second. Our units are helping us to realise we've done the right calculation. If we weren't sure of the times or divide or whatever, it's good to come out with kilograms per second when we're looking at the amount of salt in kilograms changing with time. Kilograms per second is a good rate to get. All right, I'm going to divide by 10 minus Q on 1,000 plus T. So that's what dq dt is. Now, we can solve that, dq dt equals that, because we are able to separate the variables in this one, because it was only fresh water that was entering the container. So we'll solve that now. dq, am I visible there? Yes, yeah. dq on q equals minus dt on 1,000 plus t. So I've just separated out the variables, and now I'm going to integrate both sides. So I end up with the natural log of q. Look, this quantity is always positive, so I'm not worrying about the absolute values in these questions with my logarithms. Okay, and then this one here is minus the natural log of 1,000 plus t and plus c. Now, at the start, the amount that I said was 100 kilos. Remember I spoke about that there was 10,000 litres, and it did say there was a kilogram for every 100 litres. So there's 100 lots of 100 litres, so there's 100 kilos of salt in there. So when T is 0, Q is 100. So natural log of 100 is equal to minus natural log of 1,000 plus 0 plus C. So C is the natural log of 100 plus the natural log of 1,000. So C is the natural log of 100,000. So now we're able to pop that back into our equation up here, and we get that the natural log of Q is equal to minus the natural log of 1,000 plus T plus the natural log of 100,000. So the natural log of Q is equal to the natural log of 100,000 on 1,000 plus T. So Q is equal to E. No, Q is just straight equal to 100,000 on 1,000 plus T. Now we should check whether that makes any sense to us by looking at when T is 0, we should have had 100 kegs of salt in there. So put T 0 and it's 100,000. It did say 100,000. And it's 100,000 divided by 1,000, which gives us 100. And as time goes on, we're dividing by a bigger and bigger number. So our quantity of salt's getting less and less and less, and that makes sense to me. So it seems that that would give a reasonable answer. So you could answer a question, how much salt would be left there after 20 seconds or whatever the question might be.